All right, today we are diving into an organ that is an absolute powerhouse, but it often flies under the radar. We're talking about the pancreas. It's really the unsung hero orchestrating our body's energy in this constant, really delicate performance. So let's pull back the curtain and see how this incredible dance actually works. I want you to just think about your last meal for a second. All those carbohydrates are breaking down into glucose. That's just simple sugar, and they're flooding into your bloodstream. So how on earth does your body handle that massive surge and keep everything in perfect balance? Well, the answer lies in a masterfully choreographed biological dance. And the maestro conducting this entire performance, you guessed it, it's the pancreas. Now, this organ is a real multitasker. It's got two massive jobs it's juggling at the exact same time. On one hand, it's a huge player in our digestive system. But on the other, it's part of our endocrine system, controlling our hormones. A true marvel, really. Okay, now here's what I find really fascinating. Look at this distribution. About 95% of the pancreas, the exocrine part, is totally dedicated to making digestive enzymes. But that critical life or death job of regulating our blood sugar, that falls to the endocrine system, which makes up just a teeny tiny fraction, like 1 to 5% of the entire organ. These little clusters of cells are called the islets of Langerhans, and believe me, they are the heart of our story today. So inside these little islets of Langerhans, we find our principal dancers, the hormones that run the entire blood sugar show. They are this dynamic duo with moves that are opposite but perfectly complementary, insulin and glucagon. So the whole point here is their opposing roles. Insulin, which comes from what are called beta cells, is anabolic. Just think of anabolic as building up or storing energy. Its main gig is to lower your blood sugar when it gets too high. Its partner, glucagon, from the alpha cells, is catabolic, which means breaking down to release energy. It jumps in to raise blood sugar when it gets too low. They're in this constant, perfect push and pull partnership.
And this chart just lays it out so clearly. Check out how dominant the beta cells are, right? They make up about 75% of the islet. They're the main producers of insulin, our lead dancer in this whole metabolic ballet. The alpha cells, which make glucagon, they take up about 20%, and then a few other cell types just fill in the rest.
Okay, so let's see how this all comes together in, a real-world scenario. Let's say you've just finished a meal. Your body is now in what we call the fed state. The music is starting, the dance is about to begin, and insulin is getting ready to take the lead. So here's how it plays out. First, those carbs from your food show up in your bloodstream as glucose. The beta cells in your pancreas, they're like little sensors, they immediately detect this spike and release insulin. Insulin then travels all through your body, acting like a key. It literally unlocks your body's cells, letting them soak up that glucose for immediate energy. But what about any leftovers? Well, insulin tells the liver to pack it away for later, storing it as something called glycogen. And boom, just like that, your blood sugar is back to a nice, stable level. This quote just perfectly nails it. It's not a competition between these two, it's all about balance. It's like a seesaw. One goes up, the other comes down, always working together to maintain stability. Scientists have a fancy word for this, homeostasis, but it really just means keeping your body in a stable, happy, balanced state. But what happens a few hours later, when you haven't eaten for a while? Well, your body enters the fasting state. And now it's time for insulin's partner, glucagon, to step onto the dance floor and have its moment. Right on cue, as your blood sugar levels start to dip, the alpha cells in the pancreas sense the change and release glucagon. Glucagon's main target is the liver. Remember that energy warehouse we just talked about? It sends a signal to the liver, telling it to break down that stored glycogen and release it back into the bloodstream as glucose. This is exactly what makes sure your brain and your muscles have a constant supply of fuel, keeping you sharp and moving even when your stomach is empty. It's amazing, right? This elegant dance of insulin and glucagon happens seamlessly inside us every single day, without us even thinking about it. But what happens when the dancers get out of step, when the timing is off? Well, to keep the performance from falling apart, there's actually a referee on the floor. And that referee is a hormone called somatostatin. It comes from the delta cells, and its job is pretty simple. It's basically the everybody calm down hormone. It has the power to tell both insulin and glucagon to take a break, which prevents them from overreacting and makes sure that seesaw of our blood sugar stays perfectly level. So why does all of this matter so much? Because when this dance fails, the consequences are really, really serious. If insulin misses its cue, sugar just builds up in the blood, leading to hyperglycemia, That's the high blood sugar that is the hallmark of diabetes. But if the system overcorrects and you get too much insulin or not enough glucagon, you can get hypoglycemia, dangerously low blood sugar. So keeping this performance running smoothly is absolutely critical for our health. So the next time you eat a meal, or even feel that pang of hunger between meals, just take a second to remember this incredible, totally unseen performance that's happening inside of you. This unbelievably complex orchestration of hormones is making sure you have the energy you need exactly when you need it. It's just a constant, amazing reminder of the remarkable biological machinery that keeps every single one of us going.